Hi, everybody. Welcome. Yeah, I just want to give a little highlight on how UC Berkeley is using cloud for teaching, a little bit different than a lot of the other things we'll be talking about this week, but a whole suite of open source tools that make it possible to teach in the cloud and to teach in the cloud at scale. So a bunch of decisions were made early on about how to teach introductory data science. One of the key ones was the first time somebody's learning to compute, it should be painless. There should be no install, no requirements, no technical requirements. And so everything that you do in this class is in the cloud and it's accessed via a browser tab. And people come to the class with whatever background and whatever machine they have, and they can do all the assignments in the class that way. There was a bunch of choices made architecturally about going with the cloud that really lent itself to being scalable. And let me talk about, like, there's the different components of scale as well. Not only is it scalable in the number of students, it's also scalable in your course staff. So there's hundreds of people involved in teaching classes who need to hand off the way the class is taught. And the cloud is really powerful for that as well. They were also made architectural choices about opening the infrastructure for other classes outside Data8. So as they were building for Data8, they built it to open it, and we can pile more classes on there. And right now we're starting sort of like an interesting longer tail where different instructors are coming up with different creative ways to apply this cloud-based teaching and keep innovating. So at the base, it's using a Kubernetes on some cloud credits to provide a Jupyter hub. Each individual student is doing all of the homeworks and labs and learning inside a Jupyter set of Jupyter notebooks that are designed for the curriculum. But to talk about scaling, this is the current flow rate. Data8's 1,400 students per semester. Data100 is 1,200 students per semester. Data102, machine learning class, 250 students per semester, and the probability class, 300 students per semester. So several large cloud-based deployments that are basically designed around using Jupyter hubs. All of the elements are there. And to work at scale, we also need auto grading. So, auto grading is working with the cloud-based tools as well. Another thing that we've been working at UC Berkeley, though, is also going across disciplines. So there's these main data science core classes. There's also connector classes, cognitive science, sociology. I can talk about that later. And we can also fit data science explorations in all sorts of other classes, biology classes, environment classes, econ classes. We can fit the ability to do exercises in Jupyter in the cloud onto the infrastructure that's built for Data8. And finally, more recently, we're starting to redesign other classes outside data science. So I'm currently working with the political science faculty to redo their lower division stats class based on ubiquitous cloud access. And it's going to be empowering to their students, and there'll be like a longer tail there as well. Here's a little just view of the portal of the number of users on at any given time. You actually get to measure when students actually sleep, which seems to be between 5 a.m. and 10 a.m. or something. But a huge number of students concurrently online, several different hubs at any given time. And jumping forward, we're also working on an open source software project on auto grading, both for Python and for R, the two main ways things are taught. You can do grading on the hub. You can do a Dockerization that will allow you to run the grading on any different machine that you want to. And then at UC Berkeley, there's a lot of teaching through Gradescope and running the Dockerization on Gradescope. So there's a current project under development. Another thing that they've done at Berkeley is made Python packages for courses. So this is for new learners to be able to access powerful tools like Pandas without having to just go straight into Pandas. But these are, pip install, anyone in the world can teach this way, widely used in the case of the data science package, and open source for people to contribute to as well. Another big project, that's not exclusive to UC Berkeley at all, that's being widely used is Jupyter Books. And this is like creating a bridge from teaching with course notes that are based on Jupyter notebooks with a command line script can generate, a free textbook out of your course notes. This type of textbook, for code-based classes, data-based classes, data visualization can really quickly make rich curricular materials out of the teaching materials for the class. So I teach this way. We have a lecture notebook that we go through in lab, and there's a way to quickly adapt this and make a free online textbook. We also do this for a lot of our documentation. There's a scalability issue here. The more expertise we have in building these textbooks, the more materials we can make. Probably most important here is the Data8 textbook, inferentialthinking.com, making it really easy and cheap to adopt across the country and in community colleges because it's based on a free textbook. So a lot has happened in the last 5 years. There's, as I mentioned before, 3,000 students a year in Data8. We have a major and a minor. But there's also been a lot of material made out in other classes. These data science modules with a rich set of classes, connector courses where the idea is you're in Data8, but you want to learn something about neuroscience or genetics or economics with the tools that you're learning in Data8. And we have a really rich collaboration where students can help build the curriculum for other students. Students that learn Jupyter Notebooks and Data8 and Data 100 can then, get involved in making curriculum for students in a biology or environmental justice class. And we think we're actually changing the arc of how people are teaching in other majors. As I already said, political science is changing, the way public health undergrad is going, the way genetics. People being able to access this much cloud this easy from any old laptop in a dorm room, it is changing the way we can teach. If you're interested in this, you can come. There's a GitHub, a bunch of free open materials we call Jupyter modules, but like examples from a wide range of different classes. If you're building data science out at your university, this is a great way to reach out to colleagues and be collaborative and use cloud-based resources as a way to, sort of create diplomacy in this area. And there's a lot of rich learning in the cloud-based space as well with these connector courses. Some of these are compute-intensive ways to teach. We had a class that undergrads, first and second years, were able to do MRI imaging, stuff that would be prohibitive just a few years ago. And with these cloud-based tools, you can get students exploring MRIs. My class is on economic models. We're getting students to do basically interactive data for all of the different things that we teach. And it would have been just way too prohibitive to do that without a cloud-based server backing us up. Anyways, if you're interested in any of this, we have a annual workshop that CloudBank has participated in a couple summers in a row. We have extensive documentation on how to use these materials, how to get your class going in the cloud, how to build out a Jupyter hub for your institution, or who to connect with. A lot of times, it's connecting faculty and the IT people at different institutions of how to get onto cloud. And a final thing I just want to say, CloudBank, UC Berkeley, and 2I2C are working together to provide Jupyter hubs for community colleges that are getting online to teaching a Data8 style stack. So that's something we're all doing is outreach, together collaboratively, getting more and more users on to cloud-based teaching. That's my presentation. Happy to follow up with anybody individually if you're interested in the educational side of things.
Thanks.